building Twitter for Android with Gradle. I'm going to be talking about that. Specifically about how this team moved from Ant to Gradle. I'm Jonathan, but first, a disclaimer. I have no idea what I'm doing. Usually I don't, but I had to learn Gradle too, so just like all of you. Luckily, Hans and his team has done a great job of making that very easy. There's a lot of documentation and there's training, so you can give him your money. But I have managed to do a few things, so let's talk about that and let's talk about me. Background. My name is Jonathan. I'm an engineer on the Android team here at Twitter. I have designed and built build systems, mostly used build systems, but I usually I worked at very small companies where we were doing J2Me and Brew, and so most of the times you don't have build systems, you don't have anything to start with. There's nothing standard with J2Me or Brew, so you're usually left to your own devices and you end up building your own build systems. Most of the time these apps have to support different key maps, screen sizes, different features, you toggle things on and off, different languages, so you end up with having over 200 build artifacts, each one uploaded to on the deck with the carrier. So most of the times I'm using Ant or Make or something custom, something like C, Perl, or shell script. See that's Perl there. It's a dark time in my life. And I also built Twitter for Android. So Twitter for Android, if you don't know, is a critically acclaimed, widely used, phenomenal app that everybody loves. That's right. So here's kind of a look at where we were before we moved. This is back in 2010. Very simple project, one committer, me, 100 unit tests, single repo, no dependencies, everything in one flat architecture. We're using Ant. Build time is 30 seconds. That's pretty good. That's not a clean build, but that's an incremental build. 30 seconds is not bad for each code change. Here's where we were with Twitter 4. This was right before we switched to using Gradle. And so we had a very sophisticated or very complicated system of Ant and IV running together. We had 15 committers, 400 unit tests, 100 UI tests, 3 Git submodules in our project. Build time, 2 minutes. And that's because we had to do a clean with every single commit. Every single change we made, we had to clean and rebuild. 2 minutes. Too many build steps, too long. It's very frustrated engineer illustrates that well. That's actually me this morning. I was leaving my desk. So the build setup usually starts like this. Check out the repo. You get your code, you clone using Git. Update your submodules, right? You have 3 submodules, so you update them. You sync your submodules because maybe updating didn't work. I don't know, maybe. Then you read a fact about submodules because nobody really understands submodules. I don't either. Then you set up your IV dependencies, and you have to run this specific script, like setup IV or whatever. But we've made a task for that, but you have to run that before you start using your IDE. Then you install the SDK tools. Then you configure your SDK tools, and then you clean. Finally, you build. Step 10, pray to God, it works. So there was a very specific problem we were trying to solve, very specific problems. One, we had a really massive build config. The build.xml was huge, and it was getting bigger and bigger by the day. Ant is not really suited for logic-based kind of like decision-making. It's not real programming language, it's a configuration system. And so it promotes things like just copy and pasting to create more tasks, basically. And that's just not maintainable. So we also needed multiple build artifacts, like building Amazon builds, which are great. And different features on and off, different purposes, multiple build artifacts, we need that. More importantly, we want to reduce our build time. So to do that, we wanted to test and build code separately, meaning we want to componentize our code into smaller chunks that are, kind of loosely coupled, interdependent but loosely coupled. So we really wanted to do that. To do that, though, we needed dependency management, which is very useful, very easy with Gradle. And we wanted to stop using submodules. Nobody should use submodules, ever. So the migration was done in 3 easy steps, and I'm paraphrasing because the first step actually took a lot of time. But we wrote all the build tasks in Gradle. And so there were problems with, we had multiple builds. We wanted to install builds side by side on one device. We tried doing the package rename. Didn't really work. So we had to write our own custom plugin to do that. Did all that, and we're trying to move off of that now, and some of my esteemed colleagues are doing most of that work. So the second thing we did was set up a private Sonatype Nexus repo, and that allowed us to publish our artifacts somewhere where we can reference on the VPN. Did that, it was very easy to do. And then we started publishing AARs to Nexus, right? You have library projects and you need to publish artifacts, you publish AARs. That's what Android library plugin creates, and so that's what we're publishing. I talk about this on my blog, but I'm going to give you kind of like the brief important bits here. The first thing is obviously apply the plugin Maven. The most pertinent piece of information here is you want to set up an archives configuration which extends from the default configuration. I don't even know if that's necessary, but I did that anyways. Like I said, I have no idea what I'm doing. Upload archives is the task that you create a closure for. The most important properties are the configuration. You assign the configuration, and you set up your POM to use packaging of AAR. That's the most important part. After that, you use upload archives. As long as you've set up all your Gradle properties and everything, it should upload it to your private Sonatype Nexus repo. So if you want to learn more about that, this is kind of the basics. The details are on my blog. This wasn't easy. There were a lot of challenges. The Android plugin was still early, so it was a work in progress. It was hard to get going when it was that early. I started right after Google I/O of this year, so that was maybe a little too early. I ended up having to fix a couple of bugs myself. I couldn't wait anything, just pushed it. Luckily, I got the approvals and went in, could move right along. And like I said, we had to work around by creating custom plugins. You might have to do that too. Android Studio is pre-alpha. Right now, it's pretty good, pretty decent shape. You could actually build, Hans said he was, brought to tears. We were brought to tears on the other side where it didn't actually work, right? So we were like, I
didn't mention that face.
And the project itself is undergoing ongoing development, right? There's a lot of people committing code all the time, so making a big change like this is abrasive. There's no real good time to kind of make the switch, though, so my suggestion would be just, hold hands, jump off the cliff. Just do it. And of course, our more ongoing development means more contributors, varying degrees of involvement. Some people make small commits, some people make much larger commits, but this number is, growing and shrinking continuously. So it's very hard. And so here's a developer. No IDE support, 3 sad faces stacked. So here we are today, Twitter 5. We're on Gradle, completely migrated. We have 80 committers. We've got 629 unit tests running, 151 UI tests, but we're down to 24 seconds building. That's not a clean, that's an incremental build. So that's pretty darn good. That's better than I was before, just by myself, 30 seconds. And this is getting better because we haven't completely componentized our code yet. So once we do that, you can imagine this being much, much faster. So here's our build setup now. Check out the repo. Add local properties. That's setting up your SDK config. Assemble. That's it. Everything else just works. We're using wrappers that Hans talked about earlier. It just works. You check out the repo, you build, you're done. That of course, means Android Studio had to work as well before, right? So we're at that stage where we can say this is actually possible. And so here's our developers. That's actually, that's our iOS team. Just wanted to briefly touch on incremental testing. I mentioned earlier we wanted to separate our code and test it separately, but we also wanted to make sure when we are running our tests, we're not running the full suite, right? There's no point in checking in a colors change, for example, and running all the unit tests. There's really no need for that. So what we want to do is, depending on the change that you make, run the appropriate tests only, right? So the way it works is you commit code, it kicks off a job with CI. CI comes back with some results saying, it was compiled properly and the test ran, so now you can actually merge your commit. So you go through those steps, CI compiles it, says either it fails or it succeeds. We have all these things like check style and lint and all those verification tasks that we run. Then it runs all the unit tests, every single one. 629 unit tests, all of them. You make a layout change, a color change, whatever, all unit tests run. And so verification was taking about 13 minutes. Every commit, check it into the repo. 13 minutes later, you get your verification. That's not good. So in the interest of this talk, I wanted to create and illustrate how easy it was to create a Gradle plugin, but I kind of got carried away, and I ended up creating this test closure detection thing that we actually applied and started using. It examines bytecode, very simply. You compile, it reads your classes, it determines whether there are dependencies, what classes are affected, right? So basically, what it determines is, what test should I run? Here's a set of input files, what test should I be running? That's what it tells you. I call it Stalker. It's at 0.1, so very new. But after we applied it, our total time is now down to 5 to 8 minutes. That's lint, check style, compilation, and unit test running, about 5 minutes. So that's pretty good. We're in good shape. There's a lot more to do. I've open sourced this morning, so you can go check that out. I encourage you to make pull requests for me, and that's where you can find it. Thank you.